water suppression systems. The whole thing's in a little bit of a disarray at the moment as a result of the new BS 9251, which is a 2021 code, and BS 991, which is a 2015 code, and it's about to be upgraded. So the whole thing's in a little bit of a disarray on the residential side. The commercial side hasn't changed all that much, but we kind of floundering through at the moment. But we'll try and make as much sense of it as we possibly can. So
there's one slide in, I'm going to interrupt you straight away. Request from the audience, can you lean a bit into the mic? I think the volume is a little bit low for some people, so I don't know if you can do that, just get a bit more volume.
Testing, how's that?
Yeah, that's great.
Does that feel better?
I think that's probably better. Thanks for that. Sorry to interrupt your flow. No, I'll shut up now. That's
cool. So what we'll do, we'll start off with a bit of basic fire dynamics, and that's the familiar fire triangle that we've known for years, the fuel, oxygen, the heat. But they have added another component onto that, which is this bottom part, which is the chain reaction, which is the chemical part of the chemical reaction part of the combustion process. We've all seen this formula here, the CH4 plus O2. Now CH4 is methane, O2 is obviously oxygen, H2O is water, CO2 is carbon dioxide, and because it's an endothermic reaction, you get heat. Now that's a clean burn. The only way you'd ever get a clean burn is if you actually had a mixed flame. You know, diffuse flame wouldn't burn clean. And basically, we all know that smoke's created, and that's where it starts getting a little bit complicated. And it's no coincidence, that the top doctors of fire engineers are all inorganic chemistry guys, because the chemistry can be quite insanely difficult, because different things burn, and that will create different reactions. So we all know that smoke's created, which is a symptom of incomplete combustion, together with, of course, the more dangerous CO2, the carbon monoxide, which is toxic rather than a respiratory suffocant, so to speak. So, like I said, that this fire tetrahedron, it's a good job I had it written down, because I wouldn't have even known that was a tetrahedron, but apparently it is replaced the triangle, and the chemical reaction now is part of the consideration, and it's quite important for some suppression systems, because some suppression systems try and interfere with the chemical reaction of the combustion, and they break up that reaction there. And if you break up that reaction, you can also suppress or extinguish the fire. Just a little bit more, and this the chemistry in the chain reaction effectively revolves around pyrolysis, and pyrolysis is the breakdown of the surface of the hydrocarbon, and that produces a volatile gas, and it is the gas that produces the flames. We've got three phases of matter: solid, liquid, and gas, but only gas will burn. So most of the time, the solid will then go to liquid, and then the liquid will then go to gas, and the gas will then ignite. There is certain situations where it goes straight from solid to gas. That's called sublimation, and it's not that common. Suppression and extinguishing systems may interfere with the chemistry and the chain reaction to the function. So basically, what you're taking away from this is only gas burns, and what you were going to take away from the last slide was the chemical reactions now being added to the fire triangle. I forgot about my little yellow highlighted sections. So we've got various suppression systems available for different applications. We've got sprinklers, water mist, inert gas and CO2 systems, chemical gaseous systems, foam, and the outlawed but extremely useful, the Halon 1301 system, and obviously because that's a ozone depleting gas, it's effectively been outlawed. And choosing the right system is key, and of course that's the bleeding obvious. You know, there's there is nothing scientific about that. If we get the right system, then we stand a chance of it working better. So we're going to go through the various systems. Sprinklers. Now, when we look at it in terms of the fire tetrahedron, got to get this back. I've got to start getting that into my system. If you're going to take anything, sprinklers are a fuel depleting appliance. They deplete the fuel. Yes, they certainly do cool the fire, and so they take an element of heat away from it. There's no doubt about that. But basically what they do, they will wet materials that would combust and turn them into incombustibles. So if it's cardboard or carpet, that carpet and the cardboard will be wetted by the sprinklers, and that will reduce the growth of the fire. And yes, of course, it will reduce the heat. Certain sprinkler systems can add foam. Liquid fires are based non-combustible on the basis of the physical barrier that the foam creates between the combustible volatile gases and the atmosphere. So that's basically how the foam tends to work. The fire is certainly cool, but the removal of the fuel prevents the spread. Sprinklers are a suppression system. They may extinguish, but that's more good luck than good management. As a general rule, they need intervention. They need the fire authority to come and finish the job off. And what we take away from that, the design principle for sprinklers is you establish the fire load, and it's the millimeters of water, which is effectively liters of water on the ground per square meter for a given duration. So the different categories and classes of sprinkler system will have different amount of water that's discharged from the heads for a given square meterage of area for a given duration. And we'll get a little bit more into that, but that's it in a sentence. So the gaseous and the gaseous systems, the inert gas. These are oxygen depletion systems. The idea is they deplace 40% of the enclosure volume with an inert gas, leaving the O2 concentrations less than 12%. And that 12% is insufficient to sustain combustion. So that's basically what they do. So small variations on performance depending upon the gas. There may be extinguishing systems. What's the most important thing with these aspects, and we tend to see them more on process buildings. There's a control over the compartment, because if you're trying to replace 40% of the enclosure volume and the doors open, it's simply not going to work. So it works really well in places like GSK where there's airlocks, in the laboratories and places like that, and they're extremely well sealed. So they know exactly how much gas that can actually be discharged into the enclosure to reduce that oxygen content down to less than 12%, and therefore extinguish the fire. They are predominantly extinguishing systems. So what we've ascertained basically from this is that there's two methods. There's either an extinguishing system or a suppression system, and the gaseous systems tend to be extinguishing systems rather than suppression. So the design principle is very simple: gas necessary to achieve O2 concentration that won't support combustion. And like I said, that's the sealing of the compartment's pretty key to that kind of thing. Then we've got the chemical gaseous systems. So there's a heat removal and a chemical reaction interference. That's the two aspects of the tetrahedron that's removed. So there's heat removed by the breakdown of flames, partly interfering with the chemistry of the combustion. Again, these are extinguishing systems, and the environment's got to be tightly controlled. And where the biggest problem is with these is that if it doesn't extinguish the fire, there's a good chance you get hydrogen fluorides developing. And one of the, if we do have a chemical gaseous system proposed, the fire authority, the first thing they want to know is what it is, because the last thing that wants to happen is a fire authority want to be wandering in. I know they'll probably have breathing apparatus and things like that, but they've got to have an awareness of whatever hazards are being placed in front of them. They not tend to be that popular because the gases are not environmentally friendly. And again, Halon 1301 surpassed in terms of performance, but banned because it was an ozone depletion gas. Design principles is the gas necessary to inhibit the chemical reaction of combustion, and it's obviously to a certain extent going to displace oxygen as well. And mist systems. And now these are best described as an inert gas system. And the inert gas in this particular case is steam. And the idea is that the steam displaces the oxygen until combustion can't be sustained anymore. It's unique. It's a unique situation where the heat of the fire actually drives the extinguishing or the suppression process. Because mist systems can be one or the other. If they are extinguishing systems, they've got to be extremely well designed and extremely well, and the environment's got to be extremely well controlled, much the same as they are with gases. But the efficiency is driven by the fire. So they work really well on large fires because the large fires got a lot of energy, and that energy turns out those water droplets into steam, and the steam will then displace the oxygen and either suppress the fire, or in certain situations it will extinguish it. The relationship between the fire and the enclosure is critical. They tend to work better in small compartments and slightly larger fires, because if the small fires don't tend to produce the amount of energy that's needed to create the steam from the droplets. So small fires can be a little bit of a problem with them. But again, that's the side of the design side. The design principles is ascertain the risk, establish the geometry of the compartment, and the ventilation is key to the compartment too. They don't work particularly well when the compartment's really well ventilated. Design fire and testing procedures key. All of the mist system codes heavily rely upon test data, to prove that they're going to be adequate in certain situations. Again, a little bit more on mist systems. And like I've already said, it can be an extinguishing system, but very difficult to control over the compartment if it is an extinguishing system. Like I said, it needs an awful lot of research and testing. Still operates as a gas cooling system due to the fine droplets, and this is really effective at preventing flashover. They need to be, like I said before, they need to be justified by full-scale and accurate testing that are at least similar to the end application. The fire and key relationships with the enclosure it's key to the extinguishing process, and the factors vary. Like I said, it's probably the only system where the fire actually drives the extinguishing or the suppression process. So the common systems. So basically we've got two common systems. We've got sprinklers and fire mist systems. Sprinklers are far more common than fire mist systems, certainly on the type of schemes that I'm involved with, you know, which are predominantly medium and high rise and large process buildings. The fire mist systems that I tend to deal with are more commercial, because they're very, very good at extinguishing processes. So if you've got a piece of process equipment, the environment is tightly controlled. They know exactly what type of fire is going to be provided or potentially provided by the piece of equipment. So they work really, really well in process situations. So basically what I've tabulated there is the 4 codes. So we've got residential, and the 2 residential codes, the sprinkler systems, the 9251. That's recently updated, the old 2014, and that's where there's a little bit of confusion, because we've got a new code, but all of the guidance documents still points to the 2014, and of course all of the work that's presently being carried out is effectively to 2014. Some of the new work most all of the new work that's proposed is being designed in accordance with the 2021 code, and that's the domestic mist code 8458 of 2015. Again, like I said, it's heavily dependent upon test data rather than empirical data that you have in the sprinkler system. The non-residential sprinkler systems 12845 2019, and the mist systems for non-residential is 8489 2016. So what you take away from this is 2 codes for the sprinklers and 2 codes for the mixed. One's for commercial and one's for residential. And that's basically. Now the 2021 code mixes up a bit of non-residential in it, because the trend is now, certainly for the medium and high rises, is that there is generally commercial development underneath. So previously under the 2014 9251, the domestic, the residential would be to 9251, and the commercial would be to 12845. And 12845 is savage when it comes to water storage. It can be quite excessive at times. So as a common sense kind of approach, which we've got to applaud, we can now sprinkle the commercial and the ancillary in accordance with the residential code, within reason. There's rules to that. We can have a quick look through some of that. Now, mist systems are what we've tended to see mist systems for more so in residential is for loft conversions and justifying open plans. So we tend to see them an awful lot in that situation. The reason why perhaps that we haven't seen them so much on the residential is mainly probably because of test data. Now, up till now, what the rule tends to be, it's sprinklers or its equivalent, and it becomes very subjective what's equivalent. Now, the proposed 991, which is the code of practice for means of escape and fire safety design for residential premises, from a bungalow up to 50 stories, is covered by that particular code, all residential. Now that is in the throes of being updated, and I've taken this out of the draft, the final draft, where we've got the new 991 is going to give us a little bit more guidance on when it's not really recommended to use a mist system. So basically any buildings over 11 meters, where the reduction in fire resistance has been mitigated. As we find out, we can, if you sprinkle a building, then you can reduce the fire resistance of the elements of structure. Where the increase in unprotected area has been mitigated, if the property is, if the development is sprinkled, you can double the unprotected area in relation to the boundary. That's the windows and the doors. Any area of the external wall that doesn't achieve the required fire resistance, that's unprotected areas. That's why you tend to see gable, on low rise, you tend to see gable ends on the boundary. And the windows to the windows and the doors are to the back and the front of the property, because the gable ends, the flank walls are generally on the boundary, and they're close to the boundary, and so that the unprotected area is limited there. Now, if the building's sprinkled, then you can double the amount of unprotected area. Where there's no provision of a fire, where no provision of fire main has been mitigated, that's not recommended in that particular situation. Increased distances of fire hoses have been mitigated. We've got various rules from dry rises of 45 meters, and we can extend that if the property, if the building's being sprinkled, but not if it's a mist system. That's what the new 9991's suggesting. Situations where the residentials, the base of an atrium or an ancillary accommodation, not really suitable for that, and in relation to balcony escape. So we've got a little bit of guidance on where mist systems are not really recommended, not as far as the code's concerned, perhaps not suitable, but that is in draft at the moment. It could change. And if at the moment, everything's relatively subjective in that relationship between mist and sprinklers. Like I said before, the new BS 9251 allows the following ancillary uses to be added to the residential sprinkler installation, subject to code conditions. And that tends to be like car parking, bin stores, concierge offices, residence stories, plant rooms, laundry, retail. These types of uses underneath the residential blocks. There's some uses that can use the same densities, the same sprinkler densities or intensities, whichever way you want to put it, as the residential. But majority of it will be at that increased 5 litres a minute density, and they need quick response heads, which the fire authority always ask for. I'll show you the difference between a quick response and a standard response head in a minute. And the head coverage is reduced to 12 square meters. Again, it's a chicken and egg, and which slide I use first in a situation like this. But if you take away ancillary and accommodation can now form part of the residential sprinkler system. That's the most important thing to take away. The numbers are not going to make much sense to you in an hour's time. But if you can take away the fact that the new code, the new domestic sprinkler code, the new residential sprinkler code will now allow ancillary accommodation to be part of the residential system. So here's the components: power supply, water supply, tank, pumps, valve sets, distribution pipework, and the sprinkler head. Now, we're going to get onto power supplies and water supplies in a few minutes. But though, if you just, for the time being, just understand that these are the components. These are the main components. Obviously, the power and the water supply needs a degree of resilience. That's key. 9 times out of 10, you need a tank, because you can take it off the mains, but the water authority are very reluctant to guarantee the flow rates. The pump or generally the pumps, there's generally 2 of them, even though in certain situations you only need 1, but it's very, very rare you ever see a sprinkler installation without 2 pumps. The valve sets are now quite controlled in comparison to what they used to be. Obviously, there's lots of valves involved. There's a valve set there that you can see, and that's an isolation valve. And that's an interface back to the fire alarm, because the second that that isolation valve is turned off, it'll send a signal to the fire alarm panel. That fella there's the flow switch. So the second that a sprinkler head goes off, water will flow through there. That switch will then alert, that interface on the flow switch will alert the fire alarm panel. That's the gauge. So keep an eye on that and make sure it's design pressure at that particular point. And that fella's there's the drain valve. So if you want to drain it down. So the valve set's it's one of the big changes in the new code. Virtually all of the valves are controlled, and you need interfaces that goes back to the fire alarm panel. So there's not a possibility of somebody turning off one of these valves and then a fire occurs. And of course, there's no water supply. Distribution pipework all tends to be CPVC these days. Very rarely do we see steel. And it seems to work really well. The main bonus of it is it's extremely smooth. So the internal friction resistance when you're doing your hydraulic calculations is substantially better than steel, and obviously it's going to be cheaper than steel. And it does quite well in a fire, I'm led to believe. It doesn't melt till around about 900 degrees, and then it chars, which helps out. And the good old sprinkler head. So we'll have a look at some of these. So there's the sprinkler heads, and I think most of us know, that there's different colours represent different temperatures in which it's going to activate. Generally around about 30 degrees above ambient, maximum ambient temperature, or if you're looking for a delayed response. If you want to delay the response as late as possible, then obviously you would use a 182. There may be reasons for that, depending upon the design strategy of the sprinklers and how resilient you want everything to be. So those are the different colours. Those are the different, and it's generally 30 degrees above ambient. So if your maximum ambient is going to be, say 40 degrees, and you stick 30 on top of that, it's got 68. Roughly, you would generally use a red bulb, but theoretically there wouldn't be anything stopping you using a green one. And to be fair, the brown one would probably be okay too. As promised, these are the 2 different response bulbs. That's the standard response bulb. It's a chubby little thing. And there it is there, it's 5 millimeters. And there's the quick response, which is considerably thinner. And you will be able to see that quite easily just by looking at it. Something you'd see in there. By inspection, and the fire authority obviously prefer the quick response heads. It crops up regular on the fire officer's reports. These are 3 sprinkler heads, and of course these fellas here, the deflector plates, they are key for the spray patterns. And this is all down to manufacturer's instructions and manufacturer's data, I should say, and design. And from left to right, that's a downward facing pendant, so the ceiling would be there. That would be an upward facing pendant. As you can see, the water would be deflected back down again. So that's an up face, and that would be a down facing pendant close to the wall, and it would deflect the water away from the wall theoretically. So what to take from that? The deflector plates will dictate the spray flow pattern. That's probably the most important aspect of that. I thought I'd fling this one in. This is the current pattern at the moment. Nobody wants to look up at the ceiling and see ugly sprinkler heads. So these are the concealed sprinkler heads. And basically, there's a cover plate, and that's held on to the sprinkler head by 2 or 3 spots of solder. And when the heat from the fire starts to affect the sprinkler head, these fellas will fall off. And the second that fella falls off, then the deflector plate will instantly drop. And when you get up to the desired temperature of the particular bulb, then obviously the bulb will break, and the water will then discharge, in accordance with the spray pattern of the deflector plate. So that's basically what most people. That's the trend. Most people are using these because virtually every residential block now that we're dealing with are all sprinkled. And even blocks that don't need sprinkling at under 11 meters, the trend in the pattern is to sprinkle them, and they're always the heads, and that's the mechanism. Concealed cover in position, solder fix and cover breach, deflector plate drops, bulb fractures as temperatures reach, and then the water discharges. That's a full schematic, gives an idea of what's going down, of how it works. We'll start with the tank, and that kind of shows this would probably be the new Cat 4 system, and we'll talk about that. Like I say, sometimes these slides have come out. It's difficult to know which direction to which order to put them in. Because everything seems to be chicken and egg. So, but this is the tank, and this particular system appears to be the new Cat 4 system, where effectively that's 2 tanks. It's 2 tanks, and you can see there's 2 water supplies coming from the same probably boosted cold water supply. So they discharge into 2 tanks. We've got 2 outlets into 2 separate pumps, and that will discharge the water into this distribution. We'll have we'll have a valve set there that we've similar to that, a vertical discharge distribution pipe and horizontal distribution pipe. Now, it works very similar, from a hydraulic point of view, it works very similar to your radiators at home, if anybody's balanced their own radiators out. Because if you can imagine, the 2 things that's going to make a hydraulic difference to this system is the head, the distance from the pump to the highest, from the water line of the tank to the highest and most distant sprinkler head. So you can imagine that by the time the water pressure gets there, it's not going to be high, or it's going to be substantially lower than what it would be for, say, this sprinkler head, which is the closest to the system. And it's a bit like your furthest radiator in the house. And if you haven't balanced your radiators, if all your valves are open and your central heating kicks in, then one radiator, this closest one, will get hot really quick, and the radiator that's furthest away will warm up really slowly. So what the idea is that you can put an orifice plate in here, which makes that hole slightly smaller. So it needs more pressure to get through to that sprinkle head and less to that, and obviously it balances it up a little bit better. That's your first port of call. The second port of call is that all of these sprinkle heads, if we go back, all of these sprinkle heads have got different, or can have different size holes in them, and they're called K factors. So the bigger the K factor, so if you've got a K factor sprinkle head that's 120, it's got a bigger hole than it would have if it's a 40, which is going to have a smaller hole. So the idea being is that these sprinklers here will have small small holes, which will be small K factors, and these sprinklers here, which are going to be subject to less pressure, have got bigger holes, and that balances it all out. Otherwise, you get a huge amount of water coming out of this sprinkler, and you get a nominal, well, you'd get the design pressure out of this sprinkler, and you get probably 3 times as much out of that one. So that's a bit of a knowledge on how these things are balanced up. It's no different to your HVAC. If that was a HVAC, there'd be a volume control damper there. So that one would be closed, or 3/4 closed, and that one would be fully open. So it gives you kind of idea, you know, how these fellas are balanced up. Otherwise, this sprinkler here would discharge a lot of water, and this sprinkler here would discharge, you know, what it was designed to do, which is what you would design this sprinkler head for is about 1/2 bar. But you'll probably find you're getting 2 bar at this one, because you'll need 2 bar at this one to get 1/2 bar at that one. So that kind of gives you an idea of how the things are balanced, up. Like I said, generally there's always 2 pumps, but not necessarily wired in like this. This is a new way of wiring them in for Cat 4. When I'm saying Cat 4, this is for buildings over 18 meters high. Under 18 meters high, you don't need 2 pumps, but generally everybody does put 2 pumps in. The pipe network, as you can see, it's really, really simple. That's it. You know, so basically that's your riser. That horizontal distribution pipe would go along the common area of your flats, and then each one of these pipes would disappear into the flat, generally above the flat entrance door, together with the communications cable, your cold water supply, and electricity supply. So they'll all generally go through the same fireproof letterbox with a bit lock. And then you can tie it up that way. I think I mentioned it before. All of these valves now are all highly monitored. Well, not highly, they are monitored, and they go back to, they'll be interfaced back to the fire panel. So if any of these are open, you know, accidentally left that fella open or accidentally left that fella open, there'll be another isolation valve there, there'll be a flow valve there, and sometimes there's an isolation valve in every unit. And there really should be, and it's touch and go whether those isolation valves need to be controlled. It's not controlled in the code, as far as I'm aware, but it's, you know, it'd be ridiculous not to have them controlled. Either that, or you'd lock them open, find somewhere of doing that. So the valves are monitored. Always go back to the fire alarm. Generally there's not a separate fire alarm panel for the sprinkler, because most fire alarm panels now have got so many inputs that's capable of taken from interfaces, that you would just generally add it onto the interface of the existing fire panel. But if the existing fire panel doesn't have the legs to take the interfaces from the valve sets, and of course, you know, whether there's low water in the tanks, then you would end up with a different valve set. Now, suppression systems in terms of fire safety, they change literally everything. This was a document we knocked together. We have a little fire safety group at HBC, and we put this together. And everything in yellow there, all of this down on the left-hand side is all the different elements of fire safety. Evacuation strategy, travel distances, fire alarm, number of stairs, stair widths, all that kind of stuff down that side. Along here is the various factors that affect these. And as you can see, the one that affects virtually everything is the use of the building, or purpose group as we call it, or risk profile if you're a BS 9999 person. But for all intensive purposes, this is the use of the building, and it virtually affects everything. Then the next in the list is the height of the highest floor or the depth of the lowest basement, and that makes a big, that affects virtually everything too. And then sprinklers are the next in line. So sprinklers can change all of these aspects that are highlighted here. And to make it simple, we kind of put them together for you. So sprinklers or their equivalent can reduce fire resistances. 90 minutes fire resistance can, for residential properties over 18 meters can be dropped down to 60 minutes. Compartment sizes can be increased in schools. We're looking for 2,000 square meters. They can go higher if it's compartmented. Travel distances may be increased, but that's predominantly commercial, non-residential, apart from one situation which I'll go through. Space separation of buildings, that can be increased if you're using suppression. Hose distances from fire mains, that can be increased 45 to 60 meters or 75 meters. Dwelling layouts, they can go open plan and increase travel distances if possible. Common corridor lengths in flats, they may increase the length of them. The ventilated common corridors, they can increase. Firefighting shafts may not be necessary if it's sprinkled, certainly in the case of hospitals. I think hospitals is the only case where sprinklers can have an effect on it. In fact, I think it almost is. But hospitals, if you go over 12 meters in hospitals and it's sprinkled, then you don't need firefighting lifts. But if you go over 12 meters in hospitals and it's not sprinkled, then you do. In 9999, it reduces the fire growth factor by 1. In 9999, there's 4 fire growth factors. There's 1 which is slow, 2 medium, 3 is fast, and 4 is ultra fast. 4 is not allowed, simple as that. If you've got 4, you must sprinkle it down to 3. But effectively, it reduces that growth factor by 1. So what it's doing, it's recognizing that sprinklers reduce the growth rate of fires. That's what you've got to take away from that. But the sprinkler installation must be in accordance with the sprinkler systems for domestic and residential, which are these two. Must be in accordance with them to comply with that. This is in a little bit more detail. Extremity of the dwelling, if it's in excess of 45 meters from a firefighting appliance. If it's sprinkled, it can be extended up to 75, but it must be a category 2 or an OH1. So any old sprinkler system won't do. We'll talk a little bit about categories in a minute. Extending travel distances in communal areas. Again, Cat 2, OH1 is the standard. Open plan ground floor loft conversions can be Cat 1, or what tends to be used an awful lot in that situation is things like plume mist and auto mist, the mist systems. I think they're quite well tested for those kind of circumstances. Open plan flats and extended travel distances, again Cat 2. A reduction in fire resistances, sprinklers can justify, but again, OH2 or Cat 2. And what they do say is you need 60 minutes duration. Now, category 2 generally only has to operate for 30 minutes, but what they're saying is, well, if you're going to reduce the fire resistance, 60 minutes is burnout. 60 minutes is a golden rule in fire resistance. My golden rule in fire resistance is there to protect the fire service. So any reductions in fire resistance, the first thing I'm on the phone to is, or I'm picking a consultation out, is to the fire authority. Because it's, you know, we should, as users of the building, we should be out in 2, 3, 4, 5 minutes. It's the fire resistance is 60 minutes and higher fire resistances. They're there to protect the fire service. So the last thing they want to be doing is fighting a fire in a building that may collapse. So key with, if you ever need if you ever think it's necessary to reduce the fire resistance for one reason or another, then the fire authority is key. So the above are examples of table 2 of 991. There's 23 examples in total. Those were not the important ones, but the ones that I thought was the ones that was worth mentioning. But there's 23 in total. And like I say, the situation's in a little bit of disarray until the new 9991 comes in, together with an updated version of ADB. So all those 3 documents are all consistent with each other. You know, up till that point, there's a degree of subjectivity to it all. And like I say, so what you're going to take away from this slide is the sprinklers used for mitigation may change the design of the sprinkler system. Like I'm saying, you know, that situation there, if you're going to change fire resistance, it's a Cat 2, so, but you'd have to increase the duration of it. So that's what you would take away from that particular slide. So now I'll have a bit chat about the categories. And these are the 4 categories now that's in 925121. There's a new category emerged, the Cat 4. But Cat 1, single dwelling houses, flat, HMO, boarding house. Cat 2, blocks of flats less than 18 metres. Small residential care homes, sheltered housing. Cat 3, residential care homes, more than 10 residents, student accommodation, and hostels. And then we've come into this fella. Now, it's those 3, that category is quite a low category. It only needs the sprinklers to operate for 10 minutes. Those 2 categories are kind of joined at the hip. They're a 30-minute duration. But the amount of water that they will dump on the floor will differ, but predominantly they're 30-minute durations. And the Cat 4, this new Cat 4 for 18 metres and plus, is a 60-minute system. And the basis of that is that, you know, when I dug down into it, because I thought 60 minutes, you know, we're going to end up with an awful lot of storage for water, as you'll find out, you know, that the longer that duration that water's got to, that the sprinklers have got to operate for. And it's only generally 2, a maximum of 4 heads, the bigger the storage. But what they say is that sometimes it can take them quite a while to set, the fire authority can take quite a while for them to set up at high altitude. So that was why they went for the, you know, they went for the 60 minutes. I think the fire authorities must have had a lot of input into that. But we've got this new category 4, which we've never had before. That's the commercial, different categories. Again, it's a slide for information. We've got low hazard, and it's predominantly for buildings of less than 30 minutes fire resistance. You know, perhaps single story or 2-story shops, very small ones. Compartments less than 126 meters squared, low fire loads. I have never seen a sprinkler system designed to low hazard before. It all kind of hops in around on OH1. Now, OH1, you can design residential sprinklers to OH1, and that would be what you would design it to. And the problem is the water storage. The water storage is far more onerous in this code than it is for 9251. But those, and when you look at it, those are the uses that is being compared with residential. You know, hospitals are generally low fire loads. You know, they're very careful about having combustibles around. Libraries, you know, plenty of combustibles there. Restaurants, again, plenty of combustibles there. Schools, not too bad. And offices, not too bad. And then, of course, the way, so it goes OH2, OH3, OH4, and then it goes into high hazard, you know, for process buildings and such like that. You know, I'll probably see one of them, you know, once a year or something like that. So it's very rare you ever see anything above. It's very rare you ever see that. Well, I haven't seen that, simple as that. And it's very rare you ever see anything above OH4. And OH4 is the high hazards above that, and then the storage hazards and stuff like that. So again, different building uses will fall into different categories. Now, what I was talking about earlier is the duration is how long the sprinkler system is expected to operate for. So the Cat 1 for the single dwelling house, 10 minutes. That's all it needs to operate for. But if it runs off the mains, if it's mains fed, then theoretically it could run forever. Whether it runs at the right, if it's on a tank, then you only need 10 minutes of water supply in the tank. But as the water's going out of the tank, then the water will be coming into the tank to fill it up. So you'll probably get a little bit more than 10 minutes. Category 2s and 3s are almost entirely tanks. It's very rare you see category 2s or category 3s on tanks. It is possible. We'll have a quick chat about mains later on in the session, in probably the next 10 minutes or so. And then we've got the category 4 for the 18 meters high, and like I said, it's 60 minutes. It's a big jump on what was the case in 2014. The densities. So all we're looking for here, we're looking for 1 or 2 heads that's going to discharge at that density rate, 2.1 litres a minute per square metre, that is. So if it's 10 square metres, and then it would be 21 litres a minute. It would come from that particular sprinkler head. So if there's 2 sprinkler heads in the room, you would calculate for 2. If there's 1 sprinkler head in the room, you would calculate for 1, but you would use the bigger number. But again, you know, this kind of stuff's all written down. I'm just making you aware of, you know, that the duration and the density and the heads is all part of the hydraulic process. And as you can see, Cat 2 and Cat 3 is very similar. Like I said, Cat 1's low standard, same as LH1's are low standard. Cat 2 and Cat 3, not a great deal of difference, but you may, if you've got 4 heads in a particular room, say a communal area, then you would have to calculate for 4 heads rather than 2 heads going off. So generally, the maximum you would calculate is for 2 heads. But for category 3 and category 4, you could be calculating that 4 heads in your system was going off. If we went back to that, it would effectively, you know, if the maximum situation is you would calculate those 4 heads going off. So you would work out the internal friction of that pipe, that bend, all of that gubbins around there back to the tank. And then the static head, and that would more or less dictate the pump, because if any of these 4 go off, it won't require as much pressure as those 4 going off. So worst case scenario, you're working on 4 heads going off. Generally, you're working on 2 heads going off. So it's not a huge amount of water. Generally you can be talking about 100 litres a minute. You'll be looking at for the system. So that kind of gives you an idea of what's going down. The commercial's slightly different insofar as you've got to work on areas of operation. So you would automatically multiply up your densities by your area of operations. So that would, that one there would be for as an example, that would be 300, and that one there would be 360 liters a minute would be needed for that. So straight away you're seeing there's almost 3 times as much water in that OH1 system that would be used for these fellas. So it's quite an onerous code as 12845, and hence that's why the new 2021 version will allow commercial premises of a certain size to be sprinkled off the residential system. So this is 9251. This is the extent of coverage and the position for sprinkler heads. I'm just going to run through it quickly. Like I said, it's pointless running through actual numbers and stuff because we'll forget about it relatively quickly. All we really need to know is that there's been substantial changes from the 2014 code. And what it's saying is that generally, what used to be the case is bathrooms under 5 square meters were exempt, didn't need a sprinkler head. But now, if there's white goods in them, because people are putting washing machines in the bathroom, if there's white goods, electric showers or heaters, they need a sprinkler head. Enclosed staircase, normally exempt, but the linings have got to be Class B, and it says even the flooring, which if you've got carpet on your enclosed staircase in your residential property, it's not going to achieve Class B. I find that one a little bit odd, but it's there. You don't have to sprinkle ceiling voids or roof voids, riser shafts, providing that the Class B and the fire resistance, which there will already be, if they're running through, they'll already have a minimum of 60 minutes fire resistance for the riser shafts. So you don't have to sprinkle them. Cupboards and pantries, they go a little bit overboard on this one as well. So anything under 2 square meters or a maximum 1 meter dimension doesn't need to be sprinkled, but you can't have a consumer unit in it. Something that's got a consumer unit and theoretically need a sprinkle head, or white goods. That's quite common as well on some of the, it's a new trend that the washing machine and the tumble dryer are being located in the hall of the protected entrance hall, in the storage, a cupboard off the protected, of the entrance hall to the flats. And then it goes on to say you can only have 1 light. So if you have 2 light bulbs in it, theoretically you need a sprinkle head. So I thought that was pushing it a little bit. I can rest assured if we opened up a cupboard door and there was 2 light bulbs in it, we wouldn't be stopping the job and asking you for a sprinkle head in there. But obviously, if there's a consumer unit or white goods in there, then we would do. But I think we draw the line on on an extra light switch, on an extra light luminaire, sorry. Attached buildings, they haven't changed without direct, so they're external. Plant rooms for the water pumps and the water storage now needs to be sprinkled in accordance with 9251. So, like I said, what's to take away from this is the new 9251 has got changes and is different from the code. And they're roughly the changes in relation to what's exempt for coverage.
Les, I'm going to interrupt. We're running a little bit over on time. I don't know how many slides left to go, but I wondered whether it'd be an opportune moment just to throw in a couple of questions. So if anybody does have to go promptly, at least we get those answered. Would that be acceptable to you?
Absolutely.
There's 2 questions. One from Isabel. A 9251 category 2 system in a sheltered housing development for over 55s, people like you and me, well, decrepit people, would you consider a secondary power supply necessary?
Well, theoretically, no. But having said that, I tell you what, there's a clause in there that says for vulnerable people like me and you. So what it says is if you're, say, for obviously for sheltered sheltered accommodation, everything's happening now is everything's going out to sink, isn't it? A normal flat block is now got lots of old people in like us. Sheltered housing's now turned into nursing homes. Nursing homes now turning into care homes now turning into nursing homes. Nursing homes turning into hospitals. So what they've said is that if the people in the block are vulnerable, then you go for an enhanced water and power supply. And to be fair, the fire authority tend to pin that. They tend to stick that on their reports. The second that they see is for vulnerable people, they'll automatically ask for enhanced water supply, enhanced power supply, so a secondary power supply, and sometimes and often a supplementary supply from the outside that the fire brigade can tap into. You know, if I go right back to the start of the slide, that pipe there goes into the top of the tank, and that goes to the outside, so the fire brigade can supplementary feed the tank. And the reason for that was because it should have been a Cat 3 and it was a Cat, and we ended up putting a Cat 2 in. But the same kind of rules applies for vulnerable people. So that's basically what it says.
Oh, okay, so really, yeah, it's a judgment call, and we've probably a few fire service colleagues out there saying, well, our view would be, and that would be relevant, wouldn't it? So yeah, so thanks for that. That's just hopefully that answers Isabel. The second question we've had is about which we're always going to get with the relaxed planning permitted development rules. If you're extending upwards a block of flats, so the additional flats would be over 18 metres, would we expect sprinklers to be retrofitted in the existing lower level flats? Now, I don't know if you want me to lead in on that, because I've had some involvement in that at BCA level. BCA, Building Control Alliance, is a national group where private sector building control meets with public sector people like myself. We told the government, they asked us about the legislation when they brought it in, and we told them this would be a grey area that everybody would be asking about, and they really left it to us to pick the bones out of the legislation and make decisions. The decision round the table was that yes, you do need to retrofit sprinklers to all the lower level flats if you raise the block to above 18 metres floor level. Les, do you agree with that? Does that fit in with your way of thinking?
I don't see how there's any choice. I don't see how we could possibly approve anything else, to be fair.
No, that was the school of thought, as I say, public and private sector. So that's the way it's going to go. Obviously, if somebody wants to put forward a very cleverly fire engineered solution, then we're always open-minded to those. But apart from that, the default position will be put them in. So that's the answer to that one. So as I say, apologies, we've run a bit over, but if Les, if you conclude now, just run through your last slides and conclude, and hopefully people will be able to hang around for a bit longer, and then we'll wrap it up. I know I don't think there's too long to go now. No,
I think there's only 4 slides to go. So.
Okay, well, take it away. Sorry to interrupt.
Yeah, no problems. This is the coverage and the position. Again, this is just a bunch of numbers that nobody's going to remember. We're going to ping out a PDF of this, so you know, it's basically just saying, you know, the maximum area covered by a sprinkler is 25 square meters or manufacturer's data. They need to be between 2.4 and 5.5 apart. Don't really want to be more closer than 2.75 to the edge of the enclosure. Potential of shielded fire to be taken into account. Located away from heat producing appliances, common sense kind of stuff. Pendant upright sidewalls and sloping sprinklers strictly in accordance with the manufacturer's details and code positioning. It should say minimum distance, not maximum, minimum distance 100 millimeters away from any wall. There's a new part in the new code, which I've highlighted there, about shadowed areas, and you're allowed 1.4 meters of shadow area where it's very difficult for the sprinkler to actually reach it. Whereas as we spoke about earlier, the idea of the sprinkler is it wets the area around the fire. So if there's 1.4 meters squared that's dry and everything else around it is wet, then the fire will go into decay. And that's the idea there. Bay windows may need additional sprinkle heads, but you'll see the code. So what's to take out of that is the position of the sprinkler heads are controlled. And so if you need to do a drawing, then it's just a matter of pulling the code out, and all of this is on one slide. In relation to water supply, mains water, it's possible that you can go for mains water supply. And the idea is, the theory is that you can't exceed the maximum flow of the town main. And obviously that will be in consultation with the water authority. Otherwise it creates a negative pressure in the town main, as you could possibly imagine. I don't know how the fire brigade get away with that, because obviously they'll plug into one of the hydrants at 0.5 bar and then they'll whack it up to possibly up to 10 bar. So I would imagine in situations like that, they would provide a negative pressure in the town main, but I think they would take it on the chin, you know, for that situation. However, you can use pumps to increase the pressure, because like I said, you know, you might get 0.5 bar, 3/4 of a bar guaranteed from the water authority. You know, you might need 3 bar, you know, to get to the furthest sprinkler head at 0.5 bar, you know, because you might lose 2.5 bar with internal friction and static head. So you can use pumps to increase the pressure, but the second you've got to identify with the liaise with the water authority, tell them basically how much you're going to, your supply rate's going to, your design flow is going to be, and then you add 25 or 50 litres a minute dependent upon the category. That's 25 is 2 and 50 is 3. So it's very rare. Never seen one yet. We've just had one turned down by Thames Water where they wanted to use the town main, and Thames Water wouldn't guarantee. Well, it wasn't as if they wouldn't guarantee the flow. They wouldn't even give a flow to guarantee. So they wouldn't even say, "Oh, we'll guarantee 5 litres a minute." Wouldn't even do that. So everything's going to go down to tanks. Or most things are going to go down to tanks, other than Cat 1. You'll probably get away with Cat 1, 25 litres a minute over and above, probably no more than 75. So you might get, I'm sure you'll get 100 litres a minute off the water authority. But again, you know, Thames Water Authority appeared, well, I never saw the correspondence, so I'm not going to condemn Thames, but I was led to believe that they wouldn't give a value. Tanks will be based upon the maximum flow versus the duration. So if you've got 100 litres a minute and you've got 10 minutes, then you need 3 cubic metres of storage. It's just one multiplied by the other. They may have a supplementary feed that allows the fire service to connect from the outside. I showed you that a couple of minutes ago, which I think is a great idea. You know, and that effectively, theoretically, if they connect to that, gives the duration of the sprinkler system infinite duration. Enhanced water supply may be necessary where the building is for vulnerable people or Cat 4, which is basically what we talked about, what Isabel was asking about. This is generally split tanks, 2 pumps, and backup power for the individual pumps. We're getting close, guys. Electricity supply for category 1, 2, and 3. It's basically you take a distribution board off. If that's the main landlord's distribution board, and that is the main fuse, then you take another distribution board off to the sprinkler system just before that. And that is for categories 1, 2, and 3 is satisfactory. And like I said, the electrical supply depends upon the category. Now, if that was for vulnerable people, like what Isabel was talking about, then you would need a secondary supply, which generally is battery, or what's commonly called UPS, uninterrupted power supply. And because there's 2 pumps, you need 2 UPSs, 2 batteries. And like I say, that's new. I think I might even have it here. And there's the electrical supply for, sorry, that's not the electrical supply, it's a water supply actually. It's electrical supply for Cat 4. So it's a primary power as Cat 1, 2 and 3. So it goes off the distribution board, it goes off the main before the landlord's distribution board. And then there's plus backup supply to each pump. So each pump needs a different, if it's on UPS, which is battery, uninterrupted power supply, 1 for each pump, or a diesel pump, or an alternative supply from another substation. That's, I could discuss that for half an hour on its own, because that's different from what's being proposed in the new Treble 9.1, but that's another story. So again, electrical supply depends upon category and depends upon vulnerability. So if there's a degree of vulnerability that people like me and Trevor are both over 55, then straight away, if me and Trevor are living there, we want 2 pumps. Well, we want 2 pumps, a diesel pump and primary power, because we don't move too well these days. And the last one is down to certification. So basically, at stage 4, we want a full set of detailed plans of the sprinkler installation, indicating the position of the major components. Hydraulic design calculations for the schemes also necessary. So we get that at stage 4, which is full plans, and we would discharge your condition straight away on receipt of that. And in a completion stage, we want a commissioning certificate for each installation and provide prior to the certificate being issued. Data sheets of the installation should be provided and stored as close to the pump as possible. That we check that out on final inspection. So we want the data there. So if anybody was maintaining it, they know exactly what the capacity of the pump is. They know exactly where the interfaces for the fire alarm would be for all of those valves that we showed. And ladies and gentlemen, that's it. A little bit over time, and I apologise for my conduct. Trev.
No problem, Les. Thanks very much. And thanks to the audience. I noticed there's quite a few fire safety people in the audience, and thanks for not heckling Les. But then maybe it shows that he does know what he's talking about, because there was a lot of contradictions in there. Did Les break the record? No, I doubt it very much. Anyway, we're not going to count up. Yes, I think he probably did actually, which is, yeah, I stand humiliated. Yeah, thanks to you, Les. Really good as always. I personally thoroughly enjoyed that. And thank you, Rachel. I forgot to introduce Rachel, our marketing executive, in the background there, pushing the buttons, cutting out all the heckling that was going on, so nobody ever knew about it. And thanks to you, the audience. And what a great big audience it was.
So yeah, if I could just interrupt you, if people want to look out for an email, might send it out via Eventbrite with all the attachments to answers to the questions, and a reminder of my email address. If anybody wants a CPD certificate, then do email me, but I'll put that in a post-event email along with the link to the video.
Excellent. Yeah, so sorry we couldn't get those last 2 questions in. And yeah, the link Rachel send, we'll have all our past webinars, so any of the early ones that you perhaps didn't catch up on, if you're interested, you can have a look. They were a bit raw in those days, not quite as polished as Les was just now, but still quite useful, hopefully. So yeah, we'll be back soon. We've got more in the pipeline, more CPD subjects on the back burner for you. So watch this space. Rachel will be in touch and tell you what's in the calendar. And we look forward to seeing you again in a few weeks. So until then, bye for now, and see you soon.
Yeah, thank you.